Let's learn about the translation initiation process in the eukaryotes. The eukaryotes consist of the 80S ribosome, which contains the 60S and the 40S subunits. The 80S ribosome has three distinct binding sites for the tRNA. One is E site, which is also called as the exit site, the P site, which is the peptidyl site, and the A site, which is the aminoacyl site. The initiator tRNA in the eukaryotes is devoid of the modified F-meth amino acid. Instead, it only contains a normal methionine. The eukaryotic mRNA is also devoid of the Shine-Dalgarno sequence as compared to the prokaryotes. The eukaryotic initiation factors are important in the regulation of the translation process. These are EIF1A, EIF2, EIF3, EIF5B, and the EIF4F complex. The translation initiation process in the eukaryotes is basically a conversion in between the 40S pre-initiation complex to the 43S initiation complex to the 48S initiation complex and finally to the 80S ribosomal complex. The process starts when the 40S subunit is bound to the EIF3 and the EIF1A initiation factors. The EIF3 binds to the E site and prevents the premature binding of the 60S to the 40S subunit, whereas the EIF1A blocks the A site. Another initiation factor, which is EIF5B, comes bound to the GTP and also attaches itself to this 40S subunit. This complex is now called as the 40S pre-initiation complex, which contains the 40S subunit, EIF3, EIF1A, and EIF5B plus GTP. EIF2, which comes bound to the GTP, attaches itself to the initiator tRNA. This EIF2 now brings the initiator tRNA onto the empty P site of the 40S subunit. This complex is now called as the 43S initiation complex, which is like a scanning mechanism. It contains the 40S subunits, all the EIFs, and the initiator tRNA. Now comes the mRNA. The mRNA contains important features like the 5' end cap, the 3' end poly-A tail, a secondary structure, and a very important sequence, which is the Kozak sequence embedded in between the start codon. This ensures that there is an accurate start codon selection by the ribosome. A part of the EIF4F multimer, which is EIF4E, which is a cap binding protein, recognizes and binds to the 5' cap of the mRNA. Other parts of the EIF4F complex, which is the EIF4A and the EIF4G, come and bind to this 5' cap of the mRNA. EIF4A stabilizes the binding of the EIF4F onto the 5' end of the mRNA. Another protein called as the poly-A tail binding protein comes and binds to this. Now this entire complex becomes the EIF4F complex. The EIF4A gets rid of the secondary structure. With the help of the poly-A binding protein, the mRNA loops itself around the EIF4F complex. Now, the 43S initiation complex can finally attach itself on the 5' end of the mRNA. Now, this complex is called as the 48S initiation complex. This contains the 43S complex, the EIF4F complex, and the poly-A tail binding protein. Now this ribosomal complex scans the mRNA until it finds the right complementarity on the Kozak sequence. At this stage, the GTP hydrolyzes into the GDP and all the eukaryotic initiation factors exit the 40S subunit of the ribosome. When all the eukaryotic initiation factors are away from the 40S subunit, finally the 60S subunit can come and attach itself onto the 40S subunit to form the 80S ribosomal subunit. This marks the end of the translation initiation process. Now the 80S ribosome can continue with the elongation phase.